A49 incline plane. As you see, I have a 10 kilogram wooden object sitting on a wooden surface, 0-degree angle, 30-degree angle, 60-degree angle, 80-degree angle, and finally 90-degree angle. 0-degree with respect to what? That's very important, with respect to x-axis, and 90-degree with respect to what? Also respect to x-axis. That means 90-degree, the object is in free fall, and 0-degree is meaning that the object is sitting on a table. Okay, and the scenario 2, 3, and 4 is just 30-degree, 60-degree, and 80-degree angle. So what you're going to be discovering is that as you increase the angle, acceleration increases, right? 0-degree, at 0-degree acceleration is 0. At 90-degree acceleration is negative 9.8. That's what you're going to be discovering. Also, we're going to derive the equations for inclined plane. Let's dive in. First, we're going to derive the equations for, let's call it 90-degree, because this is a right angle triangle. And let's call 90 minus theta. If this is 30, this is going to be 60. If this is 45, this one going to be also 45. Let's put a 10 kilogram object on this incline. Okay. Now, let's make it red to serve our purpose. What purpose we want it to serve? We're going to copy this. We're going to bring it here. This is the purpose we want it to serve. Right? Okay. So you know where this one came from. This one came from right here. What does that mean? This line is parallel to this line. That's what it means. Okay. We're going to name it. This one is FG, the gravity. And you're going to realize that the gravity has two components, FG parallel and FG perpendicular. Okay. If this is the case, then let's draw this one. All right, so this is FG perpendicular. Perpendicular with respect to who? Perpendicular with respect to the box. As you see, 90-degree. This one is 90-degree with respect to the box. Okay, very nice. Now let's draw this one. Notice that this is the incline, and I'm going to copy this. So what does that mean? What is the name of this vector? Name of this vector is FG parallel. And FG parallel, as you see, is 0-degree with respect to the incline itself. And FG perpendicular is 90-degree with respect to the box. Okay. Now I want you to look at this small triangle, very small triangle. If you do look at this very small triangle, you're going to be noticing something. Let's call it A. Let's call it A. Let's call it B. Let's call it C. Okay. What is A? A is super easy. A is 90. What is C? To find C, I want you to consider this. I'm sure you're going to call them parallel lines. I'm sure you're going to call it a transversal. call it alpha, call it beta. Alternate interior angles are congruent, so alpha is congruent to beta. If alternate interior angle are congruent, then see what happens. If you put it over here, right? What is alternate interior angle of this one? Of course, C. So now you know C. 90 minus theta. Okay. Therefore, you know the B is theta. If you know this angle, you know this angle. If this is 20 degree, this is 20 degree. If this is 30 degree, this is also 30 degree. The acceleration of the box depends on only this angle. If this angle is 0, then acceleration is 0. If this angle is 90 degree, then the box is in free fall. If this theta is, let's say, 30 degree, it is now 30 degree. If you take a protractor and measure it, this is probably 30 degree. Then the acceleration is g sine theta. Okay. Now, I think we are ready to derive the formula. Let's bring this one over here. Okay. So now consider this instead of this one. Consider this one as a right angle triangle. Which angle is most important? Okay, we established that this angle is most important. P is most important because this angle is most important. Since this one and this one are same, this angle is most important. So we're going to find the side or equations using that angle, and that is B. Let's use SOHCAHTOA. So, Ka. What is sine? Sine theta, you know, opposite over hypotenuse. Sine theta, opposite. What is opposite? Opposite is this one. FG parallel. What is hypotenuse? FG itself. So FG parallel has equations FG sine theta or mg sine theta. Good. Now we're going to find the equations for this one. What is the equation for this one? We already found the equation for this. All right. This is the equation for that. We're going to find the equation for this. Ka cosine theta is equal to Jason over hypotenuse. Cosine theta, Jason. What is Jason? With respect to the angle B, Jason is this side, and this side has a name, FG perpendicular. Okay, and this one is FG. This one is FG. So FG perpendicular is FG cosine theta, or FG perpendicular is mg cosine theta. Okay, that's good. Now I'm going to come back over here to this right angle triangle. We're going to make this one longer. If we do make this one longer, what are you going to call this? What are you going to call this? You're going to call this normal force. Why? Because normal force is always 90 degrees with respect to what? With respect to the object, right? In this case, object is 10 kilogram. So normal force in this case is 90 degrees with respect to this 10 kilogram mass. Okay, we discovered the normal force. What would be the equation for normal force? Equation for normal force, just look at what is the other side of the normal force. FG perpendicular. What do you have for FG perpendicular? mg cosine theta. Okay, good. Now notice that I'm going to make this one longer. Okay, I did not make it. I don't know whether this one can be like this, but can never be longer than that. Okay, so this is force of friction. Force of friction is always opposite with respect to the moving body. What would be the angle? 180 degrees. If you move to the right, force of friction to the left. How many degrees? 180 degrees. All right. So if this is the case over here, then force of friction can never be more than the size of applied force. However, the force of friction can be as small as 0. Okay. However, the force of friction is 0 only when the angle is 0. In this case, angle is not 0. So force of friction is never going to be 0. So force of friction is whatever it is. We're going to figure it out by math. So the force of friction, I don't know, if this is 30 degree, of course, the force of friction is going to be less than FG parallel. So what is force of friction? Mu Fn. So mu mg cosine theta. So we have 4 equations. Fg parallel is mg sine theta. Fg perpendicular is mg cosine theta. Fn is mg cosine theta. Ff is mu mg cosine theta. Good. Now we're going to finish these scenarios. Where are they? Okay, let's go to the new page and finish them. We have a few more minutes. Scenario 1, 0 degree. Object is sitting on the box, wooden wood. A wooden box is sitting on a wooden table. 30 degree, right? 60 degree, 80 degree, and 90 degree. Okay. The object is 10 kilogram, wooden wood. Zero degree with respect to x-axis, 30 degree with respect to x-axis, 60 degree with respect to x-axis, 80 degree with respect to x-axis, and 90 degree with respect to x-axis. Few things you're gonna find. Number 1, you're gonna write scenario 1. Let's find the scenario 1. Degree, and then weight, and then FG parallel, FG perpendicular, F normal, FF, F net, acceleration, and velocity at 2 seconds. Okay, for scenario 2, scenario 3, scenario 4, and finally scenario 5. 1 and 5 are easy. Okay, so degree is 0, 30, 60, 80, and 90. Why 1 is easy? The weight is very easy. Weight is always mg. M is 10 and g is negative 9.8, so negative 98 for all of them. Okay, now FG parallel. Let's see if I have a calculator. FG parallel is You discover it. 98, well, 98 is not, you're just going to write mg sine theta, mg cosine theta, mg cosine theta, mu mg cosine theta. F that is fg parallel minus ff, f net our mass vf is equal to vi plus at. Vi is 0, of course. Okay. In this case, mg is negative 98. In this case, mg is negative 98, and so on. Negative 98, and the angle is 0 degree. So negative 98 sine 0 degree. Sine 0 degree is 0 degree, 90 degree, 1, 0, 0, 1. This is called cosine 0 degree, sine 0 degree, cosine 90 degree, sine 90 degree. Okay. So sine 0 degree is 0. 0 times negative 98 is 0. Negative cosine 0 degree, so that's negative 98. Normal force is positive 98. Yeah, this is negative 98, this is positive 98. This is force of friction. Is there any applied force acting on here? No. So the lots of students having problem today. What is force of friction on this object? Is 0. Is the force of friction 0 now? No. Why not? Let me use this analogy. There would be two scenarios, scenario 1 and scenario 2. Scenario 1, what was the source of applied force? My hand. Scenario 2, what was the source of applied force? Fg. Perpendicular. Fg is the source of acceleration. Okay, good for scenario 2. Now, there is no Fg parallel right now because Fg parallel is 0. So there is no friction. However, Fg parallel is not 0. So there is a friction. And Fg parallel is a kind of applied force. It's not a kind of, it is applied force. Applied force doesn't have to come from human being like me. Applied force can come from something like gravity itself. In this case, what component of the gravity causes this applied force? Fg parallel. And Fg parallel is responsible for acceleration of this body. And that's why force of friction is always try to equal in magnitude, opposite in direction to keep this object at rest. Will it always be able to keep it at rest? No. Okay, force of friction can only do so much. Okay, 0 degree, force of friction 0, net force is 0, acceleration 0. Okay, good. Here is 30 degree, so we have to use the calculator. So 98 sine 30. 49. So this is 49, and 98 cosine 30. Let me test this calculator. So 98 cosine 0, it should be 98. Okay, 98 sine 0 should be 0. Okay, good. This calculator is good. So 98 in this case cosine 0 degree. So 98 cosine 0 is 98. So this one is 98. Normal force is, not 0, it's 38, 30. So 98 cosine 30, and this is 85, 84.8, 84.9. Oh, let's write 85. Okay. All right. Normal force. Normal force is 85. Force of friction. Force of friction is this is wood on wood. Okay. So assuming that the object gonna be in motion, this is what I'm gonna prove tomorrow. I don't know whether I can prove it today. The tangent theta is inverse tan 0.4. Okay, so what does that mean? Angle is inverse tan 0.4. That's 21.8 degree. If theta is 21.8 degree, then the body would be accelerating. Okay, 30 is more than 21.8. So yes, there would be friction. Which one are you going to use? Of course, mu s is 0.3, 0.4, mu k is 0.3 for wooden wood. You're going to use 0.3. So 0.3 times Fn. And Fn is how much? 85. Yes, 85. 0.3 times 85. 0.3 times 85, and that is 25.5. So 25.5 is the force of friction, and that would be 49 minus 25.5, 23.5. Acceleration would be 2.35, and 2.35 times 9.8. While the acceleration is 9.8, acceleration is 2.35. So 2.35 times 2 times 2, and that is 2.35 times 2, and that is 4.7. Okay. All right, let's do this one. This one is 60 degrees. 60 degree bigger than 21.8 degree. Yes. So you have to use mu k. Anyway, what is the FG parallel? 98 sine 60, and that is 84.85. 98 cosine 60, and that is 49. All right, and then mg cosine theta, so this is 49. This is mu, so 49 times 0.3, and that is 15. And that's 15 minus 85, right? So that's 70. And that is 7. 7 times 2, 14. All right, let's do this one. 80 is bigger than 21.8. So then we have to do 98 sine 80. And that is 96.5. 98 cosine 80. 17. 17. FF is 17 times 0.3, 5 divided by 10, zero 0.5, no, 5, and the 96.5, so 96.5 minus 5, and that is 91.5 or 92, so 9.15, which makes sense. 9.15 times 9.15 times 2, 18.3. All right, we're gonna do the free fall one now, so that's supposed to be easy. So 98 sine 90 degree, 90 degrees, so 98 sine 90, which should be 98 itself, and this is 0 degree. Normal force is 0, force of friction is 0, F net would be 98 itself. Okay, and 9.8, which is obvious, which makes sense, and velocity is 19.2, 9.8 times 2, 19.6, 19.6. All right, so there you go, we completed the table. Tomorrow we'll explain this, and that's the plan for tomorrow.